Okay, so today we're going to talk about complex and imaginary numbers. All right, so based on what we've learned in class so far, looking at this, we would say that this has no solution. That's because this parabola never crosses the x-axis, so we said no solution. But there actually is a solution, and that's going to involve the imaginary numbers. Okay, so imaginary numbers are a set of numbers that are kind of in a different dimension, so to speak. Okay, so I'm just going to show you the total basics and how we're going to use imaginary numbers with quadratics. We could spend like 2 weeks on imaginary numbers, but we're just going to do one day, and I'm just going to show you how to use it with quadratics. Here's the function that goes with this graph, right? So if I do my b squared minus 4ac, right, the way we start all quadratics, so I would have 4 squared minus 4 times 1 times 5. And when I do that, I get negative 4. If I try to put negative 4 on my calculator, I'm sorry, the square root of negative 4, because remember, this is what goes under the radical, right? So we have the square root of negative 4. If I try to put that on my calculator, square root of negative 4, you get an error message, and it says non-real answer, meaning that there is no way, according to the definition of square roots, I can't find anything that would multiply together to give me negative 4, right? So 2 times 2 is 4, negative 2 times negative 2 is positive 4 again. So there's nothing there. So that's where it enters imaginary numbers. We need some way to represent this, right? So imaginary numbers come into play. So this is our number system. We kind of looked at something like this like the second week of school. So we talked about all these different numbers right here through the real numbers, right? We talked about natural numbers, integers, rational numbers, real numbers, and irrational numbers, right? So things like pi and square root of 2, things that are not perfect squares or have big long decimals. Well, now we're going to talk about like imaginary numbers and complex numbers, okay? So we're putting that into our full number system now as well. Okay, so the difference between imaginary and complex numbers are just what's attached to it. You can see right here that we use a lowercase I to represent imaginary. Now, when you're writing this, be very careful. If you notice, it's always italicized, so like it has a little tail on the end, and definitely dot it. Okay, so if I had like 2I, notice that I have a little tail and I dot it, because if I don't, if I say 2I, that looks like 21. Right, so in order to distinguish that this is actually an I, you need to make sure that you dot it, put a little tail on it, something, make it look like an I. Now this right here is just an imaginary number because it has 2 and then the I. A complex number would mean that I have a real number part with it. So I'm taking a real number 3 plus the imaginary part. So this becomes a complex number. Now, when we solve quadratics, some of your solutions will look like this. So you'll have complex solutions, and this is just imaginary. So that's the only difference between the two. So what you really need to understand when it comes to imaginary numbers is the definition, right? And this is super important. So the definition, the square root of negative 1 equals I. Okay, that's super important right there. This is very, 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 very important. This is what you need to know and understand, is that the square root of negative 1, we give it the letter I, because there's no other way to represent a negative under the radical. So we have created this imaginary number, and we represent it with I. So negative 1 is a perfect square, and the answer to that is I. And then if we just reverse that, I squared is going to give you negative 1. Okay, so that's just the reverse of that, like saying I squared is equals negative 1. That's just the opposite of that, okay? All right, so then how to actually work with these numbers, okay? So today we're just practicing simplifying square roots with negatives underneath, and then later we're going to get into quadratic equations and solving them all the way out when you end up with like complex solutions. All right, so what we're going to do is we're going to break this down into negative 1 times the square root of 24. So I haven't changed this at all. I just split it up into 2 pieces. So for now, I'm going to ignore this, and I'm just going to look at the square root of 24. First thing I look at, is that a perfect square? No, it's not. So I'm going to go ahead and do my factor tree. So I'm going to say 6 times 4, and then 6 breaks down into 3 and 2, and 4 is 2 and 2. So then we look at our pairs. Right, we have a pair of 2, so that goes out front. I have a 3 left over and a 2 left over, so I multiply those together and I get 6. Now I'm going to look at this piece. The square root of negative 1. Well, by definition, the square root of negative 1 is I, right? So this right here is I. So I'm going to put this with my solution of square root of 24. I is just like an x, right? We say 3x, we do the x after the 3, we don't do the x before the 3, right? So same thing with the I comes after the number, okay? So then my solution here would be 2I radical 6. Okay, so again, basically you're simplifying the square root of the positive number, and then the square root of negative 1 is I, and you're putting that in your solution. Okay, also just know that you can never, ever, ever have I under the radical. This can never happen. Okay, so don't ever leave the I underneath. The I, you're taking the square root of negative 1, that it's a perfect square, so that comes out as I. It no longer is under the radical. All right, if we look at negative 40, so again, break this up into negative 1 times the square root of 40. So 40 we're going to break down. I'm going to do 4 and 10. We've got 2's here and 2 and 5. I have a pair of 2's. I have 2 left over and 5 left over, so that's 10. This right here, square root of negative 1, by definition, right, is I. So my answer here is 2I radical 10. All right, the square root of negative 144. Again, break it into pieces. Now, the square root of 144 is a perfect square, and that is just 12, right? Because it's a perfect square, the square root sign is gone because we no longer need it because we already used it, right? So it just equals 12. The square root of negative 1 is I, so our answer here would just be 12I. Again, it's basically when you have a negative underneath the radical, you're just tacking on that I. All right, negative 72. So break this up into negative 1 and 72. Let's do 9 and 8. So we got a pair of 3's here and a pair of 2's. So we have a pair of 2's and a pair of 3's. So 2 times 3 gives me 6 on the outside. I have a 2 left over, so that goes on the inside. And then the square root of negative 1 is I, so I put that in there. So 6I radical 2. Okay, so again, basically you're just simplifying the square root of 72 and then again tacking on that I. All right, let's look at negative 225. So again, break it up into negative 1 and then 225. Square root of 225 is 15. Again, it's a perfect square, so no longer do I have the radical. Square root of negative 1 is I, so my answer here is just 15I. All right, so for negative 14, same thing again. We always start by breaking it into pieces, right? 14 breaks up into 2 and 7, but there's no pairs and there's nothing else I can do with it. So this is as simplified as it can get, right? I can't simplify the square root of 14. That is just as simplified as it can get. So square root of 14. Now, square root of negative 1 is I, so we put that out front. Okay, don't put it behind it because it could be mistaken for being underneath the radical. So it always goes out in front. So if you have a number that cannot be simplified under there, or it could be a prime number, then you're just going to leave that number under the radical and put the I in front. Okay, if we look at this one here, the square root of negative 23, right? Break it into pieces. 23 is a prime number. There's nothing I can do to simplify that. So that's going to stay the square root of 23. Square root of negative 1 is I, so that comes out front. So I just want you to notice the difference between this, where 23 is a prime number, there's nothing I can simplify, so it stays under the radical, and this here, where 225 is a perfect square, so it comes out, so it has no radical, okay? And then the other ones are just simplifying the radical and then putting the I with it, all right? If you have any questions, please feel free to ask.